This is an example of a 7.2 extends level percent yield problem. So the first thing we need to do is define two different terms. Theoretical yield, which we defined previously, and remember that theoretical yield, we write it down on here, is the stoichiometrically calculated amount of product you can produce based on the limiting reactant. Whereas the actual yield is the amount of product you actually, keyword, produce in the lab when you perform a reaction. So the first thing first here is if we're going to consider the equation 2Al plus 3NiBr2 yields 3Ni plus 2AlBr3. And what we need to do is calculate how much or how accurate we were in our lab process. If the information we're given says, during a lab you react 10 grams of aluminum with 15 grams of nickel 2 bromide, you have excellent lab skills and your yield is 2.65 grams of solid nickel. What's the percent yield? So first things first, we're going to treat this a little bit like a limiting reactant product, where we can list underneath our equation what we have of each thing. So let's start there. We start with 10 grams of aluminum, and we start with 15 grams of nickel 2 bromide, and our problem is telling us in the end that we produced 2.65 grams of solid nickel. If this is the information we have and it's all about nickel in the end, we want to turn both of our reactants into nickel. So let's start with 10 grams of aluminum. If I set up another bracket, I'm ultimately trying to go from grams of aluminum into grams of nickel because my answer, or my yield that I was given for what I did in the lab, my actual yield is 2.65 grams. So if my units cancel out grams of aluminum, I can turn grams of something into moles of something. If I cancel out moles of aluminum, I can go from moles of aluminum into moles of nickel. And from moles of nickel, I can go into grams of nickel. Let's double check that units cancel out. Grams aluminum, moles aluminum, moles of nickel. Ultimately, we're going to get an answer in grams of nickel. Alright, now we can put in some numbers. Molar mass of aluminum is the mass of 1 mole, is 26.9. If we look at our balanced chemical equation, for every 3 moles of solid nickel, I have 2 moles of aluminum. And for every 1 mole of nickel, I need the molar mass, which is 58.69. If I plug it into my calculator, 10 divided by 26.9 times 3 divided by 2 times 58.69, I get a value of 32.73 grams of nickel. So if I use all the aluminum I'm given, that's how much nickel I can make. What if I use, instead of all the aluminum, all of the nickel 2 bromide? So 15 grams of NiBr2. Only unit I can cancel out right now is grams of NiBr2. And I can turn that into moles of NiBr2. If I cancel out moles of NiBr2, I can turn it into moles of nickel. And if I cancel out moles of nickel, I can turn it into grams of nickel. So grams and grams, moles and moles, moles and moles. Ultimately, my answer would come out in grams of nickel. Now I can plug in some numbers. For every 1 mole of NiBr2, I need the molar mass, which is 218.5 grams. In my balanced chemical equation, for every 3 moles of nickel, I have 3 moles of NiBr2. And for every 1 mole of nickel, you have a molar mass of 58.69 grams. If you plug it into your calculator, 15 divided by 218.5 times 3 divided by 3 times 58.69, you get an end value of 4.03 grams of nickel. Now, in looking at this data, the lower amount is what we can always produce because something runs out and stops our reaction, which means that our limiting reactant, which is what produces our theoretical yield, says our theoretical yield must be 4.03 grams of nickel. The problem says that our actual yield in the lab was 2.65 grams of nickel. Using this information, we can use our percent yield equation to calculate an answer. So our percent yield is equal to the actual yield, 2.65 grams of nickel, divided by our theoretical yield, 4.03 grams of nickel, times 100. If you plug this into your calculator, you should get 65.76% yield. Now you try one.